Hey guys, this is a new project that I'm starting that I wanted to test out the OpenAI Codex. So I've always had this game project in mind that I've tried on my own several times and never really progressed very far. So I wanted to see if by using Codex I could advance what I'm doing, what I've tried to do in the past, to see what kind of things I can do with coding with Codex. So, at a high level, this is what you see as a prototype that I've been working on for, I guess, if you net out, it's probably 5, 6 hours of working with Codex, playing with it, testing it, and we'll kind of walk through the process of where I am and why I decided I'd stop where I am and make a video before I start progressing, because I think I have a real good chance of progressing this pretty far to some kind of playable demo, or even turn it into a game or something else. It's just kind of a wait and see. So let me start off with what I wanted. I just to test to see what Codex could do. So I started off with telling it that I would wanted to do an open world game, and that this was going to be a prototype that we're going to start out working with, and that I wanted just to have a 10 by 10 grid of dirt blocks in an isometric view, because I like isometric games from the 90s, just kind of being nostalgic. It's also a good way to visualize what you're working with data and data wise, and that I wanted to do a world simulation, but it was not necessary now. I just wanted 10 blocks on the screen just to see if it could do it. And I wanted to do it as a server client setup, and that I wanted to use my browser as the client. And it took it about maybe 3 minutes to put it together. Started it up, connected to the browser, and I had my little 10 blocks, a little 10 by 10. So it's 100 blocks, a 10 by 10 grid of blocks out there. And it was like, great, no issues with it creating the file, no errors, worked the very first time. So that got my hopes up. So my next steps were, now that I had 10 blocks of dirt, let's throw in some random stone blocks in there. And that was a real quick update. A couple minutes later, I had my 10 blocks mixed with dirt and stone. And so I started playing around with that. And then I said, well, I want to add plants to the game, because we're going to build a world at the end. I want a world simulation that the character's in, and have a live world around it, and not just the static world that's built that doesn't do anything, and you just wander around and perform whatever tasks and stuff that you've envisioned for this game to be played. So I added the plant, and then added another feature that I wanted to start off with grass. So a little grass tile would be placed on top of the dirt piles, and I gave parameters on the size of it, and it added the plant, and then I just gave it some simple rules to help it spread, and it did that, and it came out very easy. It was like quick test, iteration, test, iteration, test, iteration. Not too many changes were required. No errors, no debugging. It was just straight test, iteration, test, iteration. Anything it ran to, it could solve for itself. And so I find that highly encouraging on doing programming this way, because I've asked to create this game in Java, and I've never really programmed in Java in my life, but I know Java's widespread. It's probably the best code base that all these AIs have been trained against, so it should have a very high chance of success of doing things that are just almost everyday commonplace requests. So after I got the plants growing, and I said, well, plants actually need water, so let's add water to the mix. And so how do you get water? You get rain. And so I had it add a little tool for here to where I could create rain events. And so I could have the grass growing around here, have rain hit it, and by rain it would increase certain stats that would then allow it to spread and grow and spread. And that all worked. And so the next thing I wanted to do was add rabbits to it. I wanted an animal to eat the grass. And that was a quick implementation, and it started working, but it didn't quite work the way I wanted it. The rabbits ate the grass faster than it could grow because I'm playing with like very loose parameters just to get some kind of mechanization of interplay between the dirt block, the grass, and now an animal eating it. But there's no like really highly fine-tuned, defined rules and stuff. It was just to get the mechanics right, to make sure things were working, and everything was happening right with the first pass. At this point, I decided I would like talk with ChatGPT instead of researching like how much grass is grows in a square meter, because these are supposed to represent these. Each block represents a square meter tile, and it's like, well, how much grass can grow on a square meter? And it's like, well, that depends. What kind of grass is it? And it's like, well, how much food can a rabbit eat? How much grass? And it's like, dry weight or wet weight? It's like, okay. Instead of doing all this research, I'll just let ChatGPT do the research or give me the numbers, because it has more access to facts and can find it in a context-related way. And that's where I went back and explained what I'm trying to do, and then started involving the LLM to actually help me craft the world. And so we started looking at the model itself and started rechanging everything. And after going back and forth with the chat on questions and it giving answers and helping me form and change my opinions and ideas about what I want and how I want to get it, we started working on changing the water and how the water interacts and how that drives the ecology and how the plants will interact with that water ecology, and how we can stack things together to where we can have a stable, self-sustaining world that we will place our character in and do all the things and have everything that's in that world affected by things that go on in the world, and so on and so forth. And so I've gotten to that point where we are now at the stage where I'm going to start making drastic changes, because like right now you can see here I've got varying different heights of the tiles. It's all supposed to be like, right now the world is a one block deep, and that block can be from 1/10 of a meter to a full meter in height. So I've got graduated shade values of height, but we're still only 1 meter deep. And some of the next stages I'm going into is like to build real topography, to where then the water matrix can be laid down onto that, and based on certain conditions we will get permanent rivers and streams, and otherwise if I have like a rain event, that there will be temporary runoffs, and you'll see the temporary runoffs flowing on the screen if you're a player character in that, and have it feed in to the more static rivers, because a river by definition is water that runs year round in that channel. And so we'll kind of use that. And so at any point in time, usually that river's at a level. It's only when you have certain events like flooding events or drought that river will change its shape, size, and stuff. And so we can treat that as separate events. Well, we can have rain in the hills and running down little streams, and then eventually meets into a channel. And if you've had events that generate a strong enough pulse of water, then you would then trigger flood stages on a river, and that would be separate coding. So that's what we're kind of looking at. It's just one aspect of this, but it's an important aspect. And so building the terrain, letting the water come in, letting the water to be able to shape the terrain over time, as if you have any kind of event, or even slowly you have erosion. And so it's going to modify the map, but the map also drives how the water reacts. And so I'm progressing on that, but we're going to keep it at a small scale right now. But I'm I'm getting ready to blow this up. Right now what you see is a 20 by 20 grid, and we're going to blow it up to a larger size to start actually implementing and testing these things. And what I found is that everything's quicker. I can go through an iteration and test, and you can make the changes very incrementally about what you're wanting to do. Put it in, test, make sure nothing breaks. Put it in, test, make sure nothing breaks. And I will start up a new instance to where I can show you kind of what's working now, and we'll be able to track the changes as I go along, because I'm probably going to start filming little short episodes after each little iteration, just to keep a track of the progress, just to see how well Codex can handle and see what the limit is. Because that's what I'm curious, because now that I've started doing things, it's like I think I can have a world running on a single PC that has possibly like tens of millions of 1 meter square tiles. And the way you do that is you break it down into these little chunks. And my idea is that I'm running a tick system. So one tick happens about every 10 seconds, which equates out to like 10 minutes of world time. And so a lot of things will run on that tick, but then I can also separate, like my player's constantly moving around, and based on the speed, this is how far it can travel. And by knowing that, you can say this area around the player character runs in real time, but while that character is running in real time, I still have all the spare cycles that the computer can now run surrounding chunks further away in near time. And as you get further and further away, it's like I can run this area of land. It only needs to update and jump 1 hour at a time, because a lot of things don't change much in an hour. Like, how often does an animal eat? How often does it move? Do you have to track every little step? No, you don't. You just have to say it was here and now it's there. A tree growing. How much did the tree grow? It doesn't grow much over an hour. So these things can just keep advancing and ticking. You can have a world going, and then on the other things like rainfall, since a river stays pretty constant, there's only these pulses. The only time you really have to do some serious changes is that if you do trigger an event somewhere off the map that causes flooding, then that would trigger you to go into more detail in that specific area to start doing specific calculations to see tile by tile changes if you need to. But otherwise, you can keep things more at a general higher level, and then you update all the little objects that are in that area and just give them changes, because it's not, you want the world to progress around and keep advancing and changing, but it's not dependent upon your player to see it. You don't have to see it. You just have to be aware that things are going on distant from you. So that's kind of the high level concept of what I'm working with, and I don't know the details about how I'm going to get there yet, but we will go there. What I found very helpful is that once I engaged ChatGPT on this stuff, it started giving me all the little instructions that I would need to give to the agent to actually implement. And so there's no chance of me like just forgetting, and I can review everything. So I'm like functioning as a man in the middle, but I'm reviewing things, and if that's not exactly what I think I meant to come there, I can go back and forth with the agent until with ChatGPT, the LLM, to fine tune exactly what I want to give to the agent, and then feed it to the agent. Now it's clear, concise instructions that the agent can more easily understand, and there's no misinterpretation. And I found that it's been very helpful on that. So that's enough of me talking. We'll kind of reset this simulation that I have going right now and look at where I am right now. Then you can watch the progress as we go. Okay, so we started it up. Let me refresh the browser here just to make sure. So right now this is a little tree icon, and this is my grass. The land starts out dry at 0. So the first thing I have to do is start a rain event going. So I'm doing a heavy rain. It's going to last for 10 ticks. So this is the world date. I just gave it a date of 200, the year 200, March 1st, and then we started at 9 in the morning, and then it just advanced in 10-minute increments. This is the countdown to the tick. And this is the zoom level. That's one of the interesting things. Like when I started making it, once I started getting to this size, I just made a request. I go, I want to zoom at 5 levels, and we can zoom in and out. And that's all I gave for instructions, and it made the changes to the code to where I can zoom in and out. And one of the other things I also gave is that I wanted to be able to rotate. So if I right click and slide left and right, it rotates it. So my first attempt at this, when I did that rotate, I just said, click, and I want to rotate. And it gave me the 360 rotation. Of course, with an isometric view, these shapes have been shaped for you to see it at this angle. And so once you start rotating it, you start getting all the gaps because the shape itself isn't rotating and morphing. It's just an isometric tile. And so it's really sloppy. So then I came back and said, well, let's just rotate it at 90 degrees. So since the isometric view has been built for 90-degree rotations and all the edges meet up, because I'm not going for a collision detecting and all that at this stage. We're just going from tile to tile, hopping on everything, because this is a prototype. So that is one of the cool things. So I've added a tree, and let's see. This is my grass. So if I click on the tile, I can get all the details over here on the right about that tile. So the bottom of this has been added. I'm right at the point of changing to where I'm going to start using a more hydrology model for running the water. Right now it's running under the old model for water, but I'm going to be switching over to a newer model. So one of the interesting things is that on the grass, once I get the grass biomass up to a certain level, then once it gets above 80 right now, the grass will be eligible to start spreading. But for it to spread, the adjacent blocks have to have a certain soil water level threshold. It's not very high because grass doesn't need much water to be able to spread. It's like the rain event triggers it to spread, and it spreads, and as long as there's enough moisture in the soil, it'll continue spreading. Because that's one of the things about grass. So the reason why the high plains are high plains is that it gets enough water for grass to grow, but doesn't get enough water for trees to grow. And so that's why the high plains have grass only, and there's very few trees, because there's very few tree areas where there's enough water for trees to actually exist and grow. So it's just some of the things that have come up with doing the research and trying to build a world model. So another item is that I've got a compass down here in the lower right, and I basically said I want a compass, and I want the starting position to be pointing off that this face would be the north, and then when I rotate, as you see, the block as it rotates, where it's pointing, it's showing me where it's pointing off. So that's the original place. So I know that this is north, west, east, south. So you can tell after this rain event, now I did enough to where I can spawn a tree. There's enough moisture in the ground for a tree to spawn. So this is one of the rules. I said, here's an adult tree. It's nothing scaled to size. It's all just placeholders because this is prototyping. And now, after, I don't know how many ticks we've gone. I'm not doing a tick count. So we've gone 30, 40 ticks. We set off another rain event. So the grass biomass has grown up to 75%. And you can see everything's updating. So after each tick, the stats are constantly changing and updating. And after these rain events, the water soaks into the ground, or if it builds up high enough, it will flow. And I've set up basic rules. We're not yet using slope and taking into account the geometry of the land to see which way water will go. I just have some rules that if it overflows, it's going to pick a direction. But once it picks a direction, if it's, everything being equal, it will want to continue going in that direction because that's how water works. It finds its first path of least resistance and then it wants to flow that way predominantly. And over time, it will find, if it's filled up enough, it will fill into low space. And since I have stone that says it does not absorb and I don't have an evaporation rate set, then the water will collect there. And if it gets above a certain level, then it flows off into adjacent squares and gets absorbed by the dirt. But after the rain event passes for a long enough time, these low stone spots will still have a single water tile. So that's kind of all I have right now. I'm going to actually start implementing the next steps. I think the next steps are, I got to a point for the water G, but after looking at everything that we're doing for the water, is that I needed to do real terrain. So this is probably the last 20 by 20 map that I'll have, and we'll start generating terrain that has hills and stuff and more elevation differences to where I can actually see water collect and see if we can get to where water collects always at a certain spot and it keeps water at that level, and so it qualifies for becoming like stream or a river, something that has water in it all year round, or lake. We're looking at all the possibilities right now and trying to programmatically define that and say that that's what this area is going to be, and then these blocks. So everything's been driven by the block. So the block below will know whether it has a permanent stream or river above it. So that's where we are. I will come back with a new update.